We're going to be working at simplifying radical, part 3, with variables. So you can take the root of a variable if the exponent of that variable is divisible by the index. The index of a square root is 2, the index of a cube root is 3, etc., etc. When working with radicals that have variables in them, use the multiplication property to split the radicals into parts and then evaluate the roots the roots of the parts that can be evaluated. In other words, before we get started, if there is things, we're going to try to split up the radicals into things that we can take the square root or cube root of, and anything that is left over, we simply leave behind. So before we get started, I just want to consider some things, and you may have noticed I've written some stuff. X squared is equal to x squared. Now that's no big surprise, but a consequence of this is that the square root of x squared is equal to x. That is, what number multiplied to itself gives you x squared is x. Now this fact right here, well, this means what number multiplied to itself gives you x to the power 4? Well, that's x squared. So the square root of x to the power 4 is x squared. Now, what is the square root of x to the power 6? In other words, what multiplied by itself is equal to x to the power 6? Well, that's x to the power of 3. Now, if you notice, all of my indexes, as the above states, all my exponents are even. But more specifically, importantly, all my exponents of my radicals are multiples of 2. So all of my exponents are going to be divisible by 2. That's going to be an important property. Similarly here, what we have is the cube root of x cubed. What number multiplied to itself 3 times gives you x cubed? Well, that's just simply x. Now, what's the cube root? Sorry, that should have been cubed. What is the cube root of x to the power of 6? Well, using the left-hand side, we can just say, well, that's x squared, right? So what multiplied to itself 3 times gives you x to the power of 6? Well, that's x squared. Now, x to the power of 9, and the cube root of x to the power 9, well, that's really x to the power of 3. Now, notice that all my exponents were divisible by my index, and that's going to be something very important. So when we split up radicals, we have to just make sure that we split up our radicands into stuff that is that can be nth rooted. So probably best done with an example. So I'm just going to erase this and let's go. Start off very straightforward. Simplify the following radicals. Well, this is x, the square root of x to the power 4. Well, we can just simply ask ourselves what multiplied by itself twice gives you x to the power 4, and that is x squared. Now, here's a tricky one. What is the square root of x to the power of 5? Well, we're going to use the multiplication rule. Now, if you notice, I know that the square root of x to the power of 4 is simply x squared, and x to the power of 6 is x cubed, but I don't know the square root of x to the power of 5. So what I'm going to do is I'm going to split up my radical, my radicand. I know that I can figure out x to the power of 4, and what is left over? Just simply x. So using the multiplication rule now, I'm going to simply split this up into the square root of x to the power of 4 times the square root of x. So if you notice on the left-hand side, I can take the square root of that, but on the right-hand side, it is whatever's left over. So this really simplifies into x the square root of x to the power 4 times the square root of x, the square root of x to the power 4 is x squared. And I cannot take the square root of x, so this is just x squared times the square root of x. So we would write this as like this. Now, note that this is kind of burdensome and difficult, right? Let's move on to this next one. Now, maybe put a little star and say, we are going to treat coefficients and variables independently. Well, fair enough. I would think of, now this is square root. Look at my coefficient in my radicand. It is 36. I ask myself, can I take the square root of 36? Absolutely, I can. So I would write this as the square root of 36 times the square root of 4, or x to the power 4. And then I ask myself, can I take the square root of x to the power 4? Yeah, absolutely, I can, times y squared. And I can take the square root of y squared. So really, I can just apply the multiplication rule 3 times. So it looks like this. And the square root of 36 is 6. The square root of x to the power 4 is x squared. Square root of y squared is y. Well, that wasn't too exciting. But hopefully, our next examples will provide us with much more challenging